Ammonium nitrate can be explosive, and we are given the equation for that decomposition reaction. Before we do the stoichiometry, let's balance this equation. I just copied that equation where I have a little more room to show my work. There's only one reactant, so I only need to list the nitrogen once. I have 2 nitrogens, 4 hydrogens, and 3 oxygens on the reactant side. I have 2 nitrogens on the product side, 2 hydrogens. Oxygen appears twice on the product side, so I'll list them each on a separate line. I have 1 from the water molecule and 2 from the oxygen molecule. The nitrogens are balanced. I'm going to save the oxygens for last because it appears in more than one location on the product side. I'm going to multiply the hydrogens on the product side by 2 to balance out the hydrogens. I'll put that coefficient where I see the hydrogen. I also need to update that oxygen. I see there's a problem on the reactant side. I have an odd number of oxygens. So I'm going to go back to the reactant side and just double the reactant. I'm going to double these numbers. So now let's go back to the product side and rebalance the hydrogens. Also update the oxygen connected to the hydrogen, and that actually balances out the oxygens as well. The nitrogen appears by itself, so that's the easiest to manipulate. So we have our balanced equation with the coefficients 2, 2, 4, 1. Now let's do the stoichiometry. We're given mass of the reactant, and we're asked to find the total number of liters volume of gases. Now these are all gases, and Avogadro's hypothesis says it doesn't matter the identity of the gas. If you have the same number of particles, in other words the same number of moles, they're going to all take up the same amount of volume. So we don't have to do 3 separate stoichiometry problems. So we just need to recognize that there are 2, 6, 7 total moles of gases on the product side for every 2 moles of reactant. I'm getting a little bit ahead of myself, but let's start with what's given. 228 grams of ammonium nitrate. What's the first step? We need to turn the unit we're given into moles. So to go from grams to moles, we need the molar mass. And the molar mass is off the periodic table. I just copied over the elements that we need from the periodic table. So nitrogen, there's 2 of them in ammonium nitrate, has a molar mass of 14.01. So that's 28.02 grams per mole. And hydrogen, there's 4 of them, and the molar mass for hydrogen is 1.008. So that's 4.032. And 3 oxygens is 48. So the molar mass for ammonium nitrate is 80.05 grams per mole. So we're going to use that as a conversion factor to convert from grams to moles. Let's cancel out the units. And now we can convert this into the number of moles of total gases, because like I said, it doesn't matter the identity of the gas. So from our balanced equation, for every 2 moles of ammonium nitrate, 7 moles of gas was produced. And to turn that into volume, we use the molar volume because we assume this is at STP. And so 1 mole of any gas takes up 22.4 liters of volume. So let's punch these numbers in our calculator. 228 divided by 80.052 times 7 divided by 2 times 22.4. All right, so our answer to 3 significant figures, because that's how many significant figures were given, is 223 liters. And that's our final answer. Now, you could have done this 3 times, where you converted the moles of ammonium nitrate into moles of nitrogen to liters of nitrogen, to moles of water to liters of water, to moles of oxygen to liters of oxygen. And you could have added them separately and still got the same answer. It would have just taken you much longer.